This video is on lines, and a lot of this will be review. At the top, you'll see a definition of slope of lines. It says the slope, which we call m, of the line containing the points x1, y1 and x2, y2 is given by the following equation. We can either say rise over run, or change in y over change in x. Change in y is y2 minus y1. Change in x is x2 minus x1. Change always implies subtraction. And this is as long as x2 and x1 are not equal, in which case we would have undefined or vertical slope. So it says here, if x1 does equal x2, then you have a vertical line and the slope would be undefined since this results in division by 0. So we're going to just quickly calculate a few slopes of the lines L1, L2, L3, and L4 that contain the following points. So in the first one, line 1, our slope is going to be y2 minus y1, I'm getting that right here, y2 minus y1 over x2 minus x1. So we end up with a negative 5 over a negative 3, which is a positive 5/3. So if I plot those points, we have the point 2, 1, 2, 3, and the point negative 1, negative 2. If you connect those, you will see that its positive slope is a line that is traveling upwards. All right, let's look at line 2. Again, I don't really have room here to label these x1, y1, x2, y2. It'll be all crowded. You should do that so you don't make sign errors, but that's going to give us y2 minus y1 over x2 minus x1, or we have negative 4 over 1, which is slope of negative 4. So plotting the points, again, I have the point 2, 3, so it goes through that same point, and then I have the point 3, negative 1. And if you look at this line, whose slope, I didn't get that very straight, but pretend, whose slope is negative, you see that that slope is traveling downwards. All right, let's looking at line 3. Its slope is going to be y2 minus y1 over x2 minus x1, or 0 over 3, which is 0. And if you remember correctly, lines that have slope of 0 should be horizontal. So if I plot those points, again, I have the point 2, 3, and then I have the point 5, 1, 2, 3. I connect those, and yes, that is a horizontal line. That's line 3. Finally, we have line 4. Its slope is going to be its y2 minus y1 over x2 minus x1, which gives me 2 over 0, which is undefined, which means that should be a vertical line. So it goes through the point 2, 3, and it also goes through the point 2, 5. And if I connect those, you can see, yes, that is definitely a vertical line, and its slope was undefined. So that's just a quick review of positive slope, negative slope, undefined slope, and 0, the horizontal line. So it says conclusions from example 1. When the line slants upward from left to right, the slope of the line is positive. See L1. When the line slants downward from left to right, the slope of the line is negative. See line 2. When the slope of the line is 0, the line is horizontal. See line 3. And when the slope is undefined, the line is vertical. See L4. So quick review of slope and lines. And let's look at the next page. And we're going to do some graphing. It says graph the line that contains the point 3, 2 and has a slope of 3, 4. So the first thing we do is we plot the point. The point 3, 2 is right here. Having a slope of 3/4, since those are both positive, That means up 3 and right 4 from our original point. So we go up 1, 2, 3, right 1, 2, 3, 4. There's my second point, and there is the line. Let's do the same thing with the point 3, 2. So I'm going to start here again, but this time my slope is negative 4/5. Now you have to make a decision. Do you want the negative in the numerator or the denominator? When it's out front, I always put it in the numerator. And then what that means is down 4, right 5. But if you put it in the denominator, you would have up 4, left 5. And you're going to end up on the same line, not the same point, but the same line. So from this point, I'm going to do this one. We're going to go down 1, 2, 3, 4, right 1, 2, 3, 4, 5, and you can see that the line that contains those points is traveling downward, so it does have negative slope. All right, here we're going to graph these two lines given different information. In the first one, we're given an equation in y equals mx plus b form. So I'm going to say it tells me two things. It tells me that my slope is 1/2. It tells me that my y-intercept is the point 0, negative 4. So I'm going to plot 0, negative 1, 2, 3, 4 first. 1/2, both being positive, means up 1, right 2, and there's my second point, and I have graphed my line. On this second one, you have a couple choices. You could do an XY table if you wanted. I'm not going to. I'm going to rearrange my equation and get it into y equals mx plus b form. So I first subtract the 4x, and I get negative 4x minus 36. I'm going to divide each term by negative 6. And I end up with y equals a negative divided by a negative is a positive, so that's 2/3 x. Negative divided by a negative is a positive, so plus 6. So that gives me that my slope is 2/3 and my y-intercept is the point 0, 6. And again, you could have done that by doing an XY table and getting 2 points. So I'm going to plot that y-intercept. The point 0, 6 is right here. This is both positive, so it means up 2, right 3. So up 2, right 1, 2, 3, and I have my second line right there. So using the information that you were given. All right, at the bottom, you're going to see some information about equations of lines. It says each line is uniquely determined by its slope and its y-intercept, and there are 3 forms for the equation of a line. The first one is standard form, where you have ax plus by equals c. The next one, the one I use the most, is slope-intercept form, y equals mx plus b. And the one that I don't use a lot, but it is handy sometimes, is the point slope form, y minus y1 equals m times x minus x1. Now I'm going to give you some examples with each of these. Let's bring this up so you can see. So in example 4, it says find the equation of the line with slope 4, so I know that m equals 4, and it contains the point 1, 2. And we're going to do it both ways. So let's first use the point slope form. So I'm going to go over in the margin and do x, y, and m. I don't need a b on this one. My x is 1, the y is 2, the m here is 4, and I'm just going to fill in using, again, this equation. So y minus my actual y, which is 2, equals m times x minus my actual x, which is 1. Now, I'm not finished here because I have to get it in y equals mx plus b form. So I have y minus 2 equals 4x minus 4. Add a 2 to both sides, and we get y equals 4x minus 2. And that was a pretty easy way to do that one. Let's look at it, though, again, using slope-intercept form, which is the way I typically do it. Again, I'm going to label my x, y, m. At this time, I need a b. My x is 1, my y is 2, the m is 4. I just need to find b by writing y equals m x plus b. Now I'm going to fill in the x and the y. So 2 equals mx plus b. 2 equals 4 plus b. I subtract a 4, and I know b is negative 2. So I can put that together with these two pieces. So y equals mx plus b. In this case, I have to admit, I think this way was easier. In most cases, I think this way is easier. So you need to know both ways. Looking at the next one, we'll do it also both ways. Example 5, find an equation of the line that goes through the points 2, 3, and negative 4, 5. Write your answer both ways, but we're going to write it in slope-intercept form in the end. So first, using the point-slope form, I'm going to write x1, y1, and m. I can choose either one of the x1, y1s. I'm choosing this one. So it's 2 and 3. And I don't know the slope. So I'm going to have to find the slope for both of them. So it's going to be x1, y1, x2, y2. So it's going to be 5 minus 3 over negative 4 minus 2, which is 2 over negative 6, or negative 1/3. So I have to find the m in both cases. Now I'm going to write y minus y1 equals m times x minus x1, and this is where I think I'm not going to like this method. So y minus 3 equals negative 1/3 x plus 2/3. Now what I'm going to do is add a 3 to both sides. That gives me y equals negative 1/3 x. Now I have to know how to add 2/3 and 3. I have to find a common denominator, because that's 3 over 1, which is the same thing as 9/3. So that becomes 11/3. So there I have my equation. Not too bad. Now let's do it this way. X, y, m, and b. Here we always find the b. X is, again, I'm going to use 2 and 3 because those are both positive. My m is negative 1/3. Now I need to find the b by writing y equals mx plus b and filling in the 3 pieces that I have. So 3 equals m times x plus b. So 3 equals negative 2/3 plus b. So I added 2/3 to both sides, and I get 3 and 2/3 equals b, but we would not leave that as a mixed number. That is 11/3, same thing I got here. So put it together, y equals mx plus b, and I have it. You can get it either way that you prefer. All right, let's look at horizontal and vertical lines. A horizontal line has the equation of y equals b, and it has a slope of 0, and it has no x-intercept because it is parallel. Think about it, a horizontal line. It's parallel to that x-axis there. A vertical line has equation of x equals a. It has a slope that is undefined, and it has no y-intercept because it's parallel to the y-axis. So find the slope of each line. X equals negative 4. I know x equals a number is a vertical line, and so its slope is undefined because it is a vertical line. X equals radical 3 is undefined slope, again because it is undefined. Y equals 5, slope equals 0. Y equals pi, slope equals 0. It doesn't matter what y equals. If it's y equals some number, it is a horizontal. So these two were horizontal with 0 slope. These two were vertical with undefined slope. Graphing the following lines, y equals negative 3, negative 1, 2, 3. I know that y equals is horizontal, so I know it goes right through here. Now, you could also have said x, y has to be negative 3, pick 2 points, and then plot them. You would get the same thing. X equals 1, it goes through x equals 1. It is a vertical line, so it looks like this. And obviously you could have done an XY table where X had to be 1 and then you pick 2 other points for Y. All right, our last page, it says find the equation of the horizontal line containing the point 3, 2. You may use either the slope-intercept or the point-slope form of the line. It really isn't necessary, but we can. If it's a horizontal line, that tells me that m equals 0. So the point-slope form, I would have x1 equals 3, y1 equals 2, m equals 0, and I would get y minus 2 equals 0 times x minus 3, or just y minus 2 equals 0, add a 2 to both sides, and I get y equals 2. Now, was it necessary to do that? No. If you know that horizontal lines are in the form of y equals b, right there's my b, that 2. So I just would have said y equals 2. But if you want to go through it, I'll show you this way. Here I would have had an x, a y, and an m, and a b. X is 3, y is 2, m is 0, b is unknown. So in the formula y equals mx plus b, I'm going to fill in the 3 pieces I know. 2 equals 0 times x, which is 3, plus b, or b equals 2, which means my equation is y equals mx plus b, or just y equals 2. I got exactly the same thing. So let's look at a summary here. Parallel lines, talking about parallel and perpendicular, have the same slope. This is from a prior course. Perpendicular lines have slopes that are opposite reciprocals. So if one is negative, the other is positive, and they are reciprocals. 2 vertical lines are parallel. A vertical and a horizontal line are perpendicular. So it says find the equation of the line that contains the point 2, negative 3, and is parallel to this line. I'm going to use the slope-intercept form because that's just the way I am more comfortable with it. So I have x, y, m, and b. My x here is 2. My y is negative 3. I don't know the m, but I can quickly find it. In the equation, 2x plus y equals 6. If I solve it for y, I have y equals negative 2x plus 6. Right there's the slope. Since my line is parallel, I have the same slope. So now all I have to do is y equals mx plus b. So negative 3 equals negative 2 times 2 plus b. Negative 3 equals negative 4 plus b. Add a 4 and we get b equals 1, which allows me then to write y equals mx plus b. Once you have these 2 pieces, you have it. The last one, find the equation of the line that contains this point. I'm going to go x, y, m, and b. X is 1, y is negative 2. It's perpendicular to this line. So if I solve this equation to find its slope, negative x plus 6, now I'm going to divide everything by 3, and I get y equals negative 1/3 x plus 2. This slope is negative 1/3, negative. But since my slope is perpendicular, my line is perpendicular, my slope is the opposite, so positive, reciprocal, so it is 3. So now I can say y equals mx plus b. Negative 2 equals 3 plus b. Subtract a 3 and I get b equals negative 5. So I put that in over here. I have the 2 pieces I need, so y equals 3x minus 5.